has to do with the fringe field that we have seen here. I have here two parallel plates which I'm going to charge with an instrument that we have not seen before, which is called the a Wimshurst. If I rotate this crank, I can produce positive and negative charge, and this plate becomes positively charged and the other plate automatically becomes negatively charged. And I'm going to show this to you right there. That's the idea. Yeah, we'll make it. So there you see these two plates, and you see a ping pong ball. And this ping pong ball is a conductor. We put conducting paint on it. And remember when I did the demonstration with the balloon, which bounced between my head and the Van de Graaff, and every time that it bounced on the Van de Graaff, it took all the charge of the Van de Graaff, and when it bounced on my head, it took my charge, and so it went back and forth along the field lines. And that is what I want to show you now, that this ping pong ball will start to probe that field first outside the capacitor, or I shouldn't use the word capacitor, but these plates, and then I will bring the ping pong ball inside, and then you will see that the field is much stronger there. So let's first get some charge on there. And listen to the sound. Every time that it hits, it bangs. So it's following almost those field lines. And in doing that, it's actually transferring charge every time from one plate to the other. So it's nicely going around in an arc, the way you see it there. So it's clear that there is an electric field outside. I've proven that to you. Otherwise, it would never do what it's doing. So the electric field outside is not exactly zero, of course not. This plate is not infinitely large. And now I will bring this ping pong ball inside. I have to open up the gap a little. And I will bring it inside. And you see the field is much stronger. Now it's going back and forth between those very high density field lines. Very strong electric field, going back and forth. Each time that it hits the plate, it changes polarity. And this is not too different from the experiment I did with the balloon when I bounced it back from the Van de Graaff to my head and back to the Van de Graaff. Okay, stop working on that assignment. It's not an easy assignment.